In this video, we're going to solve a second order circuit here. We've got inductors and capacitors. We also have a dependent source, and you'll notice that everything's already been turned to phasors for us, so we don't have to do that step. On the other hand, we don't know what the frequency is. They don't tell it to us, but we can still follow the same steps here. Now we can choose node voltage, mesh current, source transformation, any other method we choose to use. However, in this particular case, I think mesh current is going to be the best, because you see that two of the meshes are going to have current sources involved, which will reduce our work. So we'll go ahead and call this I1, I2, I3, and I4. We can go ahead and do our loop 1 here, KVL. We'd have minus J times I1 plus 12 volts. Again, 12 angle 0 is just the same as 12. Plus 1 times I1 minus I3 equals 0. For loop 2, we have the current source in there, so we can just say immediately that I2 is negative 4. For loop 3, we also have a current source, so we say immediately that I3 is 2IX. For loop 4, we have that J times I4 minus I3 plus 1 times I4 minus I2 plus 1I4 equals 0. And then we need one more equation to relate our dependent variable to something else. So our dependent variable is Ix. And how can we relate Ix to I1 through I4? Well, Ix is right here going in the right direction. So it's the net current through the 1 ohm resistor going right. That would be I4 going right minus I3 going left. Not I3, sorry, I2. And we actually know what I2 is. I2 is negative 4, so then Ix is I4 plus 4. So let's see what we have here. We can replace Ix with I4 plus 4. So that tells me that there. And it's the only place we have Ix. So my first equation, if I write it in standard form, I'm going to have I1, 1 minus J I1, no I2, minus I3 equals negative 12. Second equation, I already know what I2 is, so I'll leave that alone. The next one is, I need to move things over, so I'm going to have an I3 minus 2I4 equals 8. And then the third one here, let's see, what am I going to have? I can use my I2 is negative 4 right here. And then what am I going to have here? I have a total of a negative J I3. And then JI4, 1I4, 1I4 is going to be 2 plus J I4. And then looks like I have 1 times negative I2 is going to be positive 4, move the other side, and it'll be negative 4. So that looks like the two equations I have there. So why don't I use those last two equations and I can solve. So I'll multiply this one by J, gives me a J I3 minus 2J I4 equals 8J. If I add down there, I3's cancel. 2 plus J minus 2J is 2 minus J I4. And then I have 8J minus 4. So I4 here is 8J minus 4 over 2 minus J. Now I could use that, solve back, find my I3, solve back, find my I1. But I want to point out something here. We're looking for V0. And that happens to only depend on I4, so I can actually not even bother finding the other currents. I can just go straight to the V0 phasor is R, which was 1 times I4. So that's going to be 8j minus 4 over 2 minus j. I'll go ahead and divide those on my calculator. So 8j minus 4 divided by 2 minus j. That gives me a negative 3.2 plus 2.4j. Go ahead and convert that into polar. That's going to give me 4 angle 143.1 degrees. And so for my final answer here, my V0 of t would be 4 cosine omega, we don't know what that is, t, plus 143.1 degrees in volts. So you see, by setting it up as mesh current, and then realizing once I found the first variable that was all I needed, I was able to save a lot of time. If you had set it up any other way, or had solved it a different way, you likely would have spent considerably more effort to get the same answer. Realize that none of them is necessarily more correct than any other way of solving it, but I personally feel this was the fastest way you could get the answer for this problem.